Something is off with Mercury. If we trust the most recent insider information, the James Webb Space Telescope has tracked down proof of a past with life structures on this honest planet. However, that is not all. Mercury might be totally different from what we figured it could be, concealing things that have been directly before our eyes from the start, and we simply haven't seen them. Investigating Mercury is thought of as beyond difficult and perilous, both for a valid justification, which we now finally know. A secret in the actual center of our solar system is a planet that scarcely anybody has had on their radar with regards to awesome discoveries in our solar system. In view of ongoing observations in which the James Webb Space Telescope was involved, researchers suspect that Mercury has a mystery it has been able to keep very well stowed away from us until now. Mercury is a rocky planet, slightly bigger than Pluto and altogether smaller than Earth or Mars. This world was thought to be too hot to hold life or any sort of vegetation. However, at that point, scientists found water stores on Mercury, and our picture of this world is slowly changing. Perhaps we need to totally reconsider our solar system. Mercury is definitely not an extremely hot world. You would imagine that little Mercury would be the most sweltering planet in the nearby planet group, hypothetically. This puzzling world ought to also be a real heater, but that is not true. Mercury is the planet that is clearly at the top of the list of planets closest to the Sun. Its distance from the Sun is just 58 million kilometers, compared to Earth's 150 million kilometers. By comparison, the hottest planet in the planetary group is Venus. Although Mercury's atmosphere is also hot, the much smaller Mercury is mild compared to Venus. Because of its small span around the Sun, Mercury is the fastest planet with an incredible speed of 47 kilometers per second. The planet finishes a full revolution in just 88 days. This speed is likely due to the gravitational pull of the Sun. Mercury's surface, with its captivating properties, is described by a varied scene. Various craters tell the story of an exciting past and land movement that might look like that of Earth. Huge bowls, such as the Caloris Basin, which measures more than 1,500 kilometers in width, are striking scenes on Mercury. Between the pits are immense plains that were likely shaped by ancient volcanic activity. Some regions show signs of contracting, indicating that the planet has cooled over time as the mantle contracted. Shocking scenes of steep cliffs and towering hills have formed. Researchers call these structures, which can be several hundred km long and up to 3 kilometers high, lobate scarps. Other typical Mercury features are the hollows, small, bright depressions that have likely formed through sublimation of elements like sulfur and potassium. At its poles, Mercury has pits that are permanently in shadow and thus stay cold enough to store water ice. This discovery looks like a minor act of God, as scientists long believed that Mercury was too warm to store water permanently. The fact that there is water on this little planet shows us that we misjudged Mercury. If we look at the actual temperatures on Mercury, it quickly becomes evident that we are investigating a world of extremes. Nevertheless, Mercury is in no way a very hot hell like Venus. Temperatures fluctuate and top out at 427 degrees Celsius during the day, but drop to around minus 173 degrees Celsius at night. Scientists attribute these extremes to the fact that the planet has practically no atmosphere to store or distribute heat. Venus, on the other hand, has one of the densest atmospheres in the planetary group, a greenhouse effect formed within a thick shell of carbon dioxide, which heats the planet to temperatures of up to 467 degrees Celsius. Mercury is very unique, and the ice shows that there might be regions on this planet that are mild in temperature. This raises the intriguing question of whether it is possible that life could exist in such narrow zones, in shadowed craters or beneath colossal cliffs and rocky outcrops that offer protection. The discovery of an alien world. Who could have imagined that the Greeks had already succeeded in finding this tiny world in 265 BC? On the scale of our solar system, you have to imagine Mercury as a pin-sized dot, just visible to simple telescopes when it passes in front of the Sun. It was the Greek astronomer Tis who was first to record the planet's position in the sky. However, it was not known how Tis found Mercury. Over the centuries, different civilizations made observations and records of Mercury, but it was often difficult to study the planet precisely because of its proximity to the Sun. It was only with the advent of modern telescopes in the 17th century that astronomers were able to make more detailed investigations and better classify Mercury for what it is, the closest of the 8 major planets in the system to the Sun. In 1631, the French astronomer Pierre Gassendi was the first to describe a transit of Mercury in front of the Sun, and he determined the planet's orbit. In 1771, the German astronomer Johann Hermann Schroer studied the rotation of the planet and made a mistake that led to a misconception for quite some time. Schroer believed that Mercury had a bound revolution to the Sun, like the Moon to the Earth. It wasn't until the middle of the 20th century that it was proven this was false. Mercury rotates very slowly on its axis, but races rapidly around the Sun, leading to the incorrect image of a bound orbit. In 1859, something significantly stranger occurred. The French astronomer Urbain Le Verrier noticed that Mercury's orbit showed inconsistencies that couldn't be explained by the gravity of the other known planets alone. To explain these deviations, Le Verrier hypothesized the presence of a previously unknown planet between Mercury and the Sun, which he called Vulcan. Astronomers at the time searched for Vulcan for many years, and there were also a few supposed sightings of the planet. However, the existence of this world was never proven. In 1915, Albert Einstein solved the mystery of Mercury with his general theory of relativity. His theory explained that the gravity of massive objects like the Sun bends spacetime, thus explaining the irregularity in Mercury's orbit. This likely put the possibility of Vulcan to rest for good, though the planet continued to intrigue science fiction writers in the 20th century. The first real images of Mercury came in 1974, when the Mariner 10 spacecraft captured remarkable detail of the planet's surface. These images revealed the smallest details of Mercury's surface in surprisingly sharp clarity. NASA's spacecraft flew extremely close to Mercury multiple times, resulting in the very first close-up pictures of the planet. The first time people saw craters and features, they recognized the true nature of Mercury. Mariner 10 not only captured Mercury in detail, but also provided us with measurement data on the planet's environment. This showed that Mercury doesn't have a real atmosphere, but just a thin exosphere of helium and hydrogen. The spacecraft was also able to measure a weak magnetic field, which was quite a shock. Until then, it had been assumed that Mercury had no magnetic field at all due to its small size. After the 1970s, Mercury became absent from the scientific spotlight for a long time. NASA did not send any more missions to this planet, which led to some speculation. The reasons generally given by NASA were that missions to Mercury would be very challenging to build and explore due to the gravitational pull of the Sun and the extreme conditions. A Mercury mission would need to be sturdily built and have a strong propulsion system to prevent the spacecraft from being accidentally consumed by the Sun. It wasn't until 2008 that NASA set out on the next adventure, the Mercury Surface Space Environment Geochemistry and Ranging Mission, or MESSENGER for short. It successfully opened the next chapter in the study of this planet, and MESSENGER also dispelled rumors that NASA no longer wanted to fly to Mercury for other reasons. MESSENGER successfully entered Mercury's orbit in 2011, and by 2015, it had provided new insights into the planet's geological history, including exciting new evidence of volcanism, images of vast lava plains, and proof of water ice in the polar craters. MESSENGER's measurement data piqued the interest of scientists, as it revealed there could be far more to Mercury than we had previously associated. Specifically, the evidence of the planet's turbulent past shows that Mercury was, and is, highly geologically active. This may suggest that we have been misinterpreting Mercury's history. Some researchers believe that Mercury was once in a different position in the solar system and was then pushed inward by Jupiter's gravity. What if Mercury, therefore, once stood in the habitable zone and possibly harbored life? Some of Mercury's features do indeed resemble those of a rocky world like our own or even Mars. Experts suspect that a planet that grew so close to the Sun from the start would look entirely different. It is therefore possible that Mercury was once in the temperate zone. James Webb is now poised to provide new insights into these questions. Thanks to the study of planets like Jupiter and Uranus, we now have entirely new impressions of the gas and ice giants. Scientists want to know whether we also need to revise the history of our local planetary system when Webb sets its sights on Mercury. The new space telescope will use special filtering techniques that will allow it to study Mercury around the Sun. The telescope is essentially destined for this task, as it was specially built to detect even tiny exoplanets passing in front of their stars. In our own solar system, the small Mercury before the massive Sun looks like such a tiny dot, but Webb can identify slight fluctuations in light and thus clearly distinguish the light reflected from Mercury from the illumination of the Sun. If this observation is successful, we will have much more precise information on the chemical composition of the surface. Scientists believe the scans will give data on whether Mercury is simply an inert and passive world, or whether there may be structures and activities here that we have previously overlooked. If the telescope finds more evidence of water on the planet, it would be a sensation. Established researchers would then need to acknowledge that Mercury is a far more complex and puzzling world than previously thought. Mercury, frequently eclipsed by its more noticeable neighbors, has held surprises that continue to fascinate researchers. Past its extreme temperatures and insufficient atmosphere, recent observations have revealed complexities that challenge our understanding of this small planet. One of Mercury's enduring secrets lies in its geological activity. Despite its small size, Mercury shows evidence of a turbulent past marked by volcanic activity and tectonic movements. The planet's surface is scarred with numerous impact craters, suggesting a history of intense bombardment. The Caloris Basin, a massive impact crater over 1,500 kilometers in diameter, stands as a testament to these ancient disturbances. Surrounding these craters are vast fields potentially formed by volcanic eruptions that once reshaped Mercury's landscape. These geological features provide insights into the planet's development and raise questions about its internal processes. Additionally, Mercury's proximity to the Sun affects its environment in extreme ways. The planet's thin exosphere consists mainly of helium, hydrogen, and trace amounts of other gases. Unlike Earth or Venus, Mercury lacks a significant atmosphere to regulate its surface temperature. This results in extreme temperature variations during the day, reaching up to a scorching 427 degrees Celsius (800 degrees Fahrenheit), while at night they plummet to a freezing -173 degrees Celsius (-280 degrees Fahrenheit). Such extreme conditions challenge the survival of any potential life forms. However, recent discoveries of water ice in permanently shadowed craters at Mercury's poles have intrigued scientists. The presence of water ice on Mercury is especially significant, as it was once thought too hot to support water in any form. Mercury's polar regions provide cold traps where water molecules could accumulate and persist indefinitely. This discovery not only expands our understanding of Mercury's composition, but also raises the possibility of resources that could support future exploration missions. In terms of its orbital elements, Mercury's proximity to the Sun results in an exceptionally fast orbital speed. Traveling at around 47 kilometers per second, Mercury completes a full revolution around the Sun in just 88 Earth days. This rapid movement, combined with its slow rotation on its axis, creates a unique pattern of day-night cycles and solar exposure. The study of Mercury has been extremely challenging for space agencies due to the difficulties posed by its proximity to the Sun. The Mariner 10 mission in the 1970s provided the first close-up images of Mercury's surface, revealing its cratered terrain and surface variations. Subsequent missions, such as Messenger, further enhanced our understanding by mapping the planet's surface and analyzing its magnetic field and exosphere. Looking ahead, the James Webb Space Telescope, JWST, promises to revolutionize our understanding of Mercury. Equipped with advanced imaging capabilities, JWST will enable scientists to study Mercury's surface structure in great detail. By observing Mercury as it transits across the Sun, JWST will analyze the planet's atmosphere and surface dynamics, providing new insights into its geological history and potential for harboring water or other volatiles. The discoveries made by JWST could potentially reshape our understanding of Mercury's development and evolution. By comparing Mercury's properties to those of other rocky planets in our solar system and beyond, scientists hope to uncover general principles governing planetary formation and habitability. In conclusion, Mercury remains an intriguing puzzle in our solar system. Despite its harsh environment and modest size, the planet continues to astonish us with its geological diversity, orbital dynamics, and potential for harboring water ice. Future missions and advancements in space observation technology hold the promise of unraveling more of Mercury's secrets, offering new perspectives on the formation of terrestrial planets and the conditions necessary for life.